Hello, and welcome to my demonstration of Part 3 of the PROG7312 portfolio of evidence. In this video, I'll be showcasing the Service Request Status Tracking System, which demonstrates the implementation of 5 advanced data structures as required: a binary search tree for efficient searching, an AVL tree for balanced operations, a red-black tree for guaranteed performance, a minute heap for priority-based processing, and a graph structure for managing relationships between service requests. Let's begin by exploring the enhanced report issues functionality. A key requirement for Part 3 was seamless integration with Part 1. I've enhanced the report issues page to capture additional information that flows directly into the service request tracking system. The form now has 3 sections. First, reporter contact information, name, phone, email, and preferred contact method, ensuring municipal staff can reach citizens for updates. Second, the issue details section now includes an urgency level selector: low, medium, high, or critical. This directly feeds into our min heap priority queue. There's also fields for additional comments and optional estimated costs. Finally, we have file attachment for photos or documents. Let me demonstrate. I'll report a critical water main break, upload a photo, and submit. Notice the system generates both a report ID and a tracking number. This is the integration point. The issue is now in both the original system and all 5 Part 3 data structures. Let's use this tracking number to monitor the request. Now we're on the service request status page. At the top, you can see statistics cards showing total requests broken down by status. Scrolling down, here's our newly submitted request in the table. Notice it shows our critical priority level, the status, and all key information. Let me click View Details. Here we see the complete request information, the progress tracker showing current status, timeline details, and most importantly, the reporter contact information we captured earlier, the urgency level, attached photo which is clickable, and additional comments. This demonstrates the successful integration between Part 1 and Part 3. Going back to the main page, let me demonstrate the filtering system. This search and filter section uses our binary search tree for efficient searching. I'll search by the tracking number we just got, and the BST performs an log n search to find it instantly. Above the table, you can see the high priority request section. This data comes directly from our min heap, which maintains priority order. The heap ensures critical and high priority requests are always readily accessible. Let me clear the search and show the other filter options. We can filter by category, status, priority level, and sort in different orders. Notice as I change filters, the system efficiently queries our data structures. Filtering by high priority, for example, leverages the heap structure. You can also see different requests with varying statuses and priority levels throughout the table, demonstrating the system managing multiple requests simultaneously. The Part 1 tracking functionality still works seamlessly. Let me navigate to Track Issue and enter our tracking number. Here's the request with a visual timeline tracker. Since it's newly submitted, it's at the Received stage, awaiting government review. The timeline shows the full progression: received, under investigation, assigned to team, work in progress, resolved, and closed. This demonstrates complete synchronization. Now let's look at the government admin side. I'll log in using the municipal admin credentials. The admin dashboard has been enhanced to include issue management for Part 3. Here we can see all reported issues including our newly created water main break request. Let me click Manage to view the full details. As the municipal admin, I have access to comprehensive management tools. I'll assign this request to the Water and Sanitation Department since it's a water-related issue. Let me update the status notes to keep the citizen informed. Water Department notified. Emergency team has been dispatched to your location. Now I'll change the status from received to work in progress using the quick actions, and save these changes. If we navigate back to the Track Issue page and enter our tracking number, notice the difference. The timeline has updated to show work in progress, the progress bar has advanced, and our status notes are now visible to the citizen. This demonstrates real-time synchronization between the government admin system and citizen-facing tracking. Let me navigate back to the service request status page to discuss how all the data structures work together. At the top, the high priority request section is powered by our min heap data structure. The heap automatically maintains requests in priority order. Critical and high priority items bubble to the top with O, log n, insertion time, ensuring urgent issues are always immediately accessible. The search functionality uses the binary search tree for O, log n, search performance. When I search by ID or tracking number, the BST efficiently locates the request without scanning the entire dataset. Behind the scenes, we also have an AVL tree which maintains perfect balance through rotations, and a red-black tree which guarantees O, log n, performance for all operations through its color-based balancing rules. The graph structure manages dependencies between related requests. For example, if fixing a water main requires road repairs afterward, the graph tracks that relationship, ensuring requests are processed in the correct order. Different status levels, pending, assigned, in progress, and completed, flow through these structures seamlessly. As requests update, all 5 data structures remain synchronized. To summarize, I've successfully implemented all 5 required data structures working together in a real-world municipal service application. The system demonstrates seamless integration with Part 1, efficient searching and filtering, priority-based processing, and relationship management between service requests. Thank you for watching my Part 3 demonstration.